A lot more to cover and share. 𝗪𝗵𝗆 providing free webinar about why pre-engineering buildings. I would like to share a few more things about 𝗪𝗆s. 𝗪𝗆s cast students for industry, making them experience an eager journey and a lasting desire for learning. We are a team of skilled people striving for better student and working professionals. Our objective is to introduce student community to industry, experience and learn, to enhance the skill list and opportunities for deserved civil graduates. Our services are structural analysis and design, structural drawings, quantity and cost estimation, land survey, design basis report, 3D modeling, elevation design, interior design, building 2D plans, bar bending schedule, and whatnot. We are a pack of services. Coming to the man behind this, Mr. 𝗪𝗏𝗪𝗏 𝗪𝗏𝗆 sir is a CEO and founder of 𝗪𝗆s. He is currently working as a structural engineer in MNC company in Vizag, dealing with US projects. He worked as an executive engineer for G+15-storied high-rise buildings in Vizag. He also worked as RCC design and detailing engineer for central, state, and for several government and private projects also in Vizag. Sir also worked as steel designing engineer in Pune, and now he's generous and adamant to provide all these webinars. And this webinar is about why pre-engineered buildings. And he's also pro at AutoCAD, Revit, ETABS, STAAD.Pro, TNX Towers, RCD, and many more architectural and civil softwares. Coming to a showman for the evening, Mr. 𝗪𝗔𝗍 Ganesh sir. We welcome you, sir. Sir completed Masters of Technology with first class with distinction in structural engineering. And he also pro in many architectural and civil engineering softwares such as STAAD.Pro, metal building software, AutoCAD, integrated land and water information system, GIS, and remote sensing software, surfer, contouring and surface modeling software. And he also familiar with international designing codes like Indian codes, ICE, DS, Euro codes. He worked as a PZ in MEIL, and he also worked as a design engineer for MEA department in Kirby Building Systems Limited. He worked in a project named Preparation of Unit Hydrograph for River Basin. He participated in several seminars like JS and many more. Good evening, Ganesh sir. We welcome you. Over to you, sir.
Hello. Am I audible to everyone?
Yes, sir, you're audible.
Yes, thank you. Okay, hello, welcome all. First of all, good evening, all of you. I hope all of you are safe in these pandemic times. Hope you are everyone safe along with your families. So first coming to starting, this is Ganesh. Working as a design engineer in Kirby Building Systems for past some years. And I'm here to share my experience and introduction to PEB in this lecture with all of you. So first, just let me share my screen so that everyone can see. My screen is audible to, sorry, visible to all of you. Hello. Is my screen visible to all of you? Please let me know. Hello. Can I assume is all of you are seeing my screen?
Yes, sir,
Just
it's visible.
yes. Thank you very much. Okay. Let's get into the introduction of PEB. How many of all of you know that the world is becoming a concrete jungle in nowadays, but the people are now realizing that PEB is a more important structure in nowadays when compared to the concrete. Uh, you all of you know that the concrete does not have any scrap value. After it dismantled, it has to be used as a rubbish only. That does not have any important scrap value. But in steel buildings, we can use the steel as a scrap, and you can mold it any shape you like. So first, these are the content in which we have to see in this lecture. First, PEB definition, that is what is meant by a PEB, and then we have to know what are the advantages of PEB, and everything like disadvantages, and the comparison between a PEB and a RCC structure, and what are the different types of PEB structures available in market, and what are the various types of PEB structures people are using for different purposes, and the different components involved in making a PEB structure, and the different types of loads to be considered when compared to RCC. There are some additional loads to be considered here. What are the load types? We'll see in this lecture. And then what is the load transfer mechanism in PEB? Nothing but how the load will be transferred from one component to another component. And then various tools available for PEB design. What are the various tools we are using in nowadays for design of a PEB structure? And then what are the different codes we are following in different countries, and then references and assignment. So I think all of you did not know about a PEB structure. We are already living in a society that is having more number of PEB structures, but I think many of the people did not know about a PEB structure you are seeing. So I think most of the people generally know about a petrol bunk or a railway station or a bus stand or a warehouse you are seeing. You can assume it as a PEB structure as of now. So what is a PEB structure? It is a simple building. Most of the components are manufactured in factory or a plant, and then these components, the components which are manufactured in plant or factory, these components has to be transported to site by using lorries or containers, etc., transported to the site, and then they will be erected by using simple connections. And then the main advantage of PEB structure is columns and rafters can be tapered. Let's show how this tapering will be done. So for example, I think all of you are seeing my screen, right? Yes, I assume that I hope all of you are seeing my screen. Suppose I am taking a 2D frame structure like this. Okay. So the bending a dead load, the bending moment of the structure will be like this. Right? So the shaded area is the bending moment diagram. So according to this, the PEB column or rafter will be designed. So for example, here you can see the bending moment will be much lesser. So the section here starting with having a lesser depth. Here you can see the bending moment is more, so that the section size will be increased like this for a column. For example, if we take a rafter, the bending moment is more here and more here, and here is the more. So you can assume a simple PEB structure has a shape like this, for example. Okay, so this is about a PEB. Nothing but when compared to the conventional steel structure, all these columns and rafters will be straightforward. Nothing but they use hot rolled beams or straighter sections, which uses heavier weight when compared to the PEB. But in PEB, according to the bending moment diagram, we'll design so that the lesser section will come here and more section will come here, so that the weight of the PEB will be much lesser than a conventional steel structure. In some of the studies, they are showing that the weight of the PEB is 30% much lesser than a conventional steel structure. So, and then next point, the advantages of a PEB structure. So the first advantage is less construction time. As I already told you, the PEB structure, most of the PEB components is manufactured in a plant or a factory, so that they directly transport these components into the site and will be erected by using simple connections. But in RCC, the temporary shuttering and scaffolding or formwork will be done, and then concrete will be laid, and there will be time for setting of concrete. But in PEB structures, there are no time for any setting or something. So there will be less construction time when compared to the RCC structure. That is the first point. And then the other point, no need of shuttering or scaffolding or formwork. There are no temporary structures need to be erected for setting of any PEB component, because all these components will be made in factory only and they will be erected inside directly. There will be no site concession. As you can see in your local, there will be some there should be some aggregate and cement bags. There should be some site, but in the PEB structures there will be no site concession, because they directly come from the plant and will be erected. So better QC means quality control can be done in plant than at site. So there will be no worry about the supervision in the site, because all the components will be done in the factory itself. And the main point is bad weather or hazardous environment affected time can be reduced, because if there is rain, you have to stop the RCC construction, because if you lay a concrete in the rain, it will be directly go with the rainwater. But in the steel, there is no worry about the bad weather conditions. You can erect at any time. Okay, and then it is extremely durable. Nothing but if you maintain the steel structure properly by using paints or something epoxy primers like that, it will be extremely durable than a RCC structure. And the main advantage here is it can be used a temporary or permanent applications. Sometimes you can see nothing but temporary hospitalizations when there is fire hazards or something, global hazards or local hazards. They will use something temporary or temporary applications like that. You can use steel structures there, because if you want to construct a temporary structure with RCC, it will take more time. In emergency services, there will not be much time for people to stay, like emergency shelters like that. You can use them as temporary applications, and you can use them as permanent applications also. And then less wastage of materials. We have to talk about this, because in RCC we have to throw the wastage of material which used after the construction of RCC, but there will be no wastage in the steel, because the sufficient amount of steel will be used in this thing, and the reduction in sound, echo, and thermal conductivity can be improved by SWP or insulation. This topic, generally most of the people worry about, generally in summer times most of the people worry about that this is a steel structure, we have to bear some heat like that. But there will be no worry, because in the modern improvements, insulation or SWP, nothing but sandwich panels are improved. Nothing but they do not conduct any external heat to the inside. They act as induction materials, and the reduction in sound echo also must have been improved. Generally most of the people, if you nothing but if there is any sound in a steel building, most of the people think that there may be resound, that will be some that will be not much well to the our ears. Nothing but so reduction in sound echo also can be improved by sandwich panel or insulation. Everything in the world has advantages and some disadvantages. So the disadvantages of PEB you will see here. The lesser availability of materials. Just now I have told you there are some sound improvement techniques like a sandwich panel or insulation. All these materials will be lesser availability when compared to the RCC structures, because you can avail sand or coarse aggregate or cement from anywhere, but you cannot avail the sandwich panels or insulation from everywhere. And then transportation charges can be higher sometimes. The main point is here, because I already told you in the first point itself, the PEB will be, the most of the components will be PEB in the manufacture, will be manufactured in the factory or plant itself. These has to be transferred to the site. I think all of you know that PEB manufacturing factories or plants are not everywhere in India. There may be at some particular places. So they have, suppose, for example, there is a plant or a factory in the Vizag itself that has to be transported to some Nellore, because there may not be a plant there. So transportation charges in that case can be higher. And then the next point, larger structures need heavy duty cranes and precision measurement in handling. The larger structures, while erecting the larger structures, nothing but some 60 or 80 meters span, there has to be some heavy duty cranes. Normal cranes will not be applicable here. So there may be need of heavy duty cranes which may not be available always, and there has to be precision measurement in handling. Suppose if they erect some rafter to the column, there has to be precision measurement. This is a heavy structure. The measurement should be a perfect. And most of the people thinks that PEB is just a warehouse. But nowadays, this point is not applicable because not all the PEB looks same. Just you can add some components like fascia, canopies, etc. All these PEBs can be as much as we like. And this the last point here is the skilled labor required and to be outsourced in case not available. Nothing bad. If you go through an 𝗓𝐶C structure, all the labors may be welcome there. But here for erecting the steel building, we need skilled labor because he has to measure the precision dimension while connecting the bolts, nothing but while connecting the column to the rafter or crane beam to the bracket. He has to be much skillful than the labor that required in RCC buildings. And this is the general comparison between a PEB and an RCC structure. Generally, the construction time, if we compare the construction time between a PEB and an RCC structure, in PEB, the construction time is less, as I already discussed in the first point of advantage. But in RCC, there will be no control over the time, and all the factors, including the bad weather, need to be considered. And the second point here is temporary supporting structures like scaffolding, shuttering. All these not required in PEB, whereas all these required in RCC. And the third point, weather effect. As I already told you, you cannot pour a concrete for a slab in the rain, but you can erect a PEB in the rain itself. So there will be minimum weather effect in case of PEB, but there may be huge effect in case of RCC structure. And skilled labor must required for PEB erection, but in RCC, for lifting and transporting of any materials, all labor are welcome. For materials, in RCC, you can avail the local available materials, but for PEB structures, we cannot use the local materials, which may not be available always. So you have to outsource the non-local materials. And the main point is here, the last point, the section sizes. In the PEB building, I already told you, the PEB structure is nothing but in the frames. We have to design according to the bending moment diagram. Where there is more moment, the section may be higher. Where there is less moment, the section may be lighter. So in the PEB, we design according to the bending moment diagram. So all these are lighter sections, whereas in RCC, all are straight. I think you can see many RCC structure. So these are comparatively heavier sections. Okay. So what are the different types of PEB structures available in our market? So first thing, this is called a rigid frame. You can see only two columns on both sides and one complete clear span rafter over these columns. So this frame is called as rigid frame. For this rigid frame, maximum practical width or clear span, we can say it has 60 meters. So you can see here taperization of column or a rafter. I think everyone is following, right?
Yes, sir.
Fine. So on moving to the second one, this is a BC1 frame. BC1 nothing but beam column 1. So we can see this as a beam or a rafter. This column will be connected to the beam. So there is only one internal column, so that we can call it as beam column frame. Nothing but simply we can call it as BC1 frame. So in this case, the clear span between any two columns can be called as module. So maximum practical width for a BC column will be 80 meters. And then if there are two internal columns in between the main frame columns, we can call the structure as BC2 structure, nothing but beam column 2. So there are two columns connected to the beams here, so that you can call them as beam column 2. Simply you can call it as BC2 structure. In this, maximum practical width module is 120 meters. So this is a multi-span building. There are generally the triangular portion or a gable portion. This is called as a gable. In this multi-span building, you can see multiple gables. This is one triangular portion and there is another triangular portion. So you can call it as multi-span building. There are two numbers of gable, whereas you can see here only one triangular portion. This is only, you can call it as BC2, or this one as BC1. This also has one internal column, but you cannot call it as BC1 building, but because there are two numbers of gables here, you can call it as multi-span building. And here is the monoslope or a single slope building. Generally, why there is some slope certainly has to be maintained in a PEB structure. Generally, if you see all these structures, all the rafters will be laid at a particular slope. You can observe here. Why all these structures has to be laid at a particular slope? Because there has to drain the rainwater. In case rain comes here, we have to drain the rainwater to a particular slope. There may be some gutters and downspouts. We will learn later on all these classes. Okay, so we have to drain the water from higher portion to the lower portion. So therefore, the minimum roof slope, according to some particular codes, 4% minimum slope has to be maintained in a particular PEB structure. So this as a single slope, because there are no other slope, only slope will be on one side. So you can call it as monoslope or single slope building. And this you can call it as lean-to. Lean-to is nothing but it is a structure which is resting on other existing structure. This is leaning towards the other existing structure, so that you can call this structure as lean-to structure. Lean is nothing but it is depending on the other structure here, you can see. So another one is a roof system. Roof system is nothing but previously we have seen if complete building is with steel, but here you can see these columns are with RCC, and simply they have provided a rafter over the RCC columns. So we are providing only a roof system here. There are no columns or guards, anything. We are providing a rafter along with purlins and sheeting above. So you can call it as roof system. And I think this is the familiar structure most of you know, because if you go to a petrol bunk, if you see technically into the particular structure, you can observe this structure. This is called as T canopy because it has the shape of T, and most of the people call it as Y canopy also, but the correct technical word is a T canopy. Okay, the column will be fixed at the base and there are two rafters on either side of column. So this is a T canopy. Generally we observe in the parking lots and petrol bunks and railway stations, platforms. You can see railway station platforms, etc. If there is only one rafter fixing on only one side of our steel column, you can call it as L canopy. You can observe this in generally bus stands and railway station platforms, etc. And the last one here is flat roof structure. Flat roof structure here itself, the terminology itself indicates that it has a flat roof. So the flat roof will be laid with concrete, as you all of you know. This will be laid with concrete. So I think most of you people doubt that. So if it is with concrete, where is the purpose of steel? So that is the thing. Okay, you can see a brown color lines here. These are the frames, nothing but flat roof frames, we can call it as. And you can see my cursor here. These are the joists. Some you can see truss like structures. You can see here. These are the joists. We can say the joists between. They are simply supported between these two beams. Nothing but mezzanine frames. Okay, you can say them as joists. Over that, there will be a deck panel. Generally, in RCC structure, before laying a concrete, they'll provide RCC contractors will provide a deck sheeting, decking. So like that, in this case also, we provide a deck sheeting. Here you can see this is the line of the deck sheeting. They have cut a section here. You can observe. So this is the deck sheeting. But in the RCC structure, after the setting of concrete, they will remove the decking, right? But in the steel building, they will keep as it is because they will pour directly concrete over the deck sheet. This is simply called as a flat roof structure. And these are the different components which involved in making a PEB structure. So first one is a frame. I think all of you, we have seen, right? Different types of frames, rigid frames, beam column frames, single slope, flat roof, and all these are frames. And then this has to be connected in the site by using base plate with anchor bolts, and this has to be connected with suppose a column and a rafter has to be fixed with a connection plate. So all these components. And then third one, purlins or guts and struts. So what are these purlins, guts and struts? We'll see in the next slide. In the next one, bracings, roof and wall sheetings, flashings, and miscellaneous accessories like skylights, wall lights, doors, windows, lowers, roof fan cups, ridge vents, roof monitors, etc. So what are all these? I'll tell you in brief here. And building additions like fascia, canopy, mezzanine, crane, internal structural partitions, etc. So I'll show all these in a particular practical building so that you can recognize whenever you see. So this is a purlin or a gut section. Simply you can see here it is like a jet section, right? So why we need to use jet section? Most of some Indian contractors or consultancies will use C sections also, but most of the people will use jet sections here. What is the purpose of using jet sections? Because you can at the end of these sections, why I'm talking the end of these sections, because you cannot transport, suppose if there is a 120-meter building or a 100-meter length building, you cannot transport a 100-meter length purlin entirely directly to the site from the plant, because transportation that much length transport may not be available, right? So you have to send them in a pieces, some particular 9 meter or 12 meter length pieces. You have to send them to the site. So if it is a jet section, after the end of the jet section, you can directly lay a jet section over here, right? You can visualize at the end of the section for lapping. Technically, we can call it as lapping at the end of the jet section. If you want to carry it to the other frame, so you have you can directly lay a jet section over this, so that you cannot disturb the connection. And then this will be called as 𝗔strut. 𝗔strut is nothing but I'll show you. So if there is a frame like this, so purlins will be like this. But at the end of the purlins, we have to use C section, because C section has much more axial load capability than a jet section. Because generally in the sidewalls we use bracing to transfer the wind force, but at the top these 𝗔strut will take the axial load transfer responsibility, so that these 𝗔strut will be used at the end of the purlins. You can see here, like that we'll use the 𝗔strut. And then the next component will be bracing. So bracing, what is the purpose of a bracing in a PEB? Bracing is nothing but it is a component which is used to transfer lateral forces only. What are the different types of lateral forces generally comes in a PEB building? We'll see in the later on stages. But as of now, you can say wind force. Suppose if through the length of the building, how the wind force can be transferred. So this wind force can be transferred by using the bracings only, like that you can see. And I have told you there is strut here. At the top of the rafter, we can say that as 𝗔strut at the completely side of the building. And there are two types of bracing. Generally, we use diagonal bracing and knee bracing, and the other one as portal bracing. So what is the diagonal bracing? You can see here, you can use some rods, solid sections like 16 mm, 20 mm, 24 mm, like rods or cables as a diagonal bracings. And otherwise, if there are any particular doors here, if there is a door, if there is a rod bracing, you cannot enter into the particular structure, so that we cannot use rod bracing if there is a door. So we have to go portal bracing. This is the portal frame bracing, we can call it. We have to use portal frame bracing in case of any doors, etc. And then I have told you there is some roof sheeting. Every PEB structure has a roof sheeting. Roof sheeting is nothing but the roof will be covered by a particular material that is called as sheeting. What are the different types of roof sheeting materials available? So generally in India, we use a single skin sheeting. Only you can see a corrugated sheet like this. Okay, that is a single skin sheeting. There are no other components in the roof sheeting. If there are no other components, we can call it a single skin. If there is a puff panel, you can see the layers of sandwich panel here. There is a top skin, there is a bottom skin, and between there is one insulation panel. This is called a brown colored portion is called an insulation panel. So there is an insulation panel between these two, so that we can call it as sandwich panel. I think most of you know what is a sandwich burgers, right? There is a bun below and there is a bun above and there will be stuff in between, right? Like most of the people eat it like, so like that only. There is a top skin and there is a bottom skin and there is a insulation panel in between them, so that we can call it as sandwich panel. The otherwise some people will use only top skin, and without bottom skin you can directly use an insulator panel. That is a client's difference, So, and there are some miscellaneous other components in a PEB model. You can see here, for example, rolled up doors. I think we can simply term it as shutters. Every shops or everything as shutters. That is, technically we can call it as rolled up doors. And I have told you there are some flashings. Suppose there is a wall sheeting here, there is a roof sheeting here. We have to cover these joint, right? We have to cover the gap between wall sheeting and roof sheeting, so that we have to put a miscellaneous trim or flashing, so that it can cover the gap between wall sheeting and roof sheeting. And likewise, the side wall sheeting and end wall sheeting, we have to cover the gap. All these can be called as trims or flashings. And you can see here roof fans in the I think in most of the warehouse structures you can observe these, right? Fans, roof fans. We can see if you are going through a train, most of the warehouses can be laid along side. You can see there are some certain fans rotating above the revolving above the roof, so they can call as roof vents. And roof monitor. Roof monitor is a specialized steel structure to allow ventilation, and by not allowing the rainwater or something. And here you can see some yellow colored line. You can see here, this is the crane structure, and yellow colored beam longitudinally, this is called a crane beam. Generally we all see in the later on stages how these can be designed. We'll see later. Okay, these longitudinal bars you are seeing, right? These are called purlins. Just now I have told you. And over that there will be a roof sheeting, and this is a sidewall sheeting, blue colored portion. Here you are seeing, right? Likewise, it is a lean-to structure. All these are yes. So I think you are seeing here, right? Suppose my cursor, you are seeing my cursor here. So there is some portion of building going over the roof. You can call it as fascia, because generally in PEB structures, I already told you, there will be a triangular portion. But most of the people did not like this triangular portion, because it can be simply identified as a steel structure or something like a PEB. So to cover this gable portion, we have to extend the sidewall portion up to a roof height, which is known as a fascia. So if you see from any side of the PEB building, if it is having fascia, you can see it as like a simple rectangle building. You cannot observe any gable or triangular portion there if it is having fascia. And then what are the different loads to be considered in a PEB? So there are three types of loads mainly considered in a PEB. First one is gravity loads. So gravity loads, and the second one is lateral loads, and the third one is self-restraint forces. So gravity loads, I think all of you know. As a civil engineer, you have to know what are the gravity loads. Gravity load, there are some certain loads comes under gravity loads. First one is the main component here is dead load. In the case of a PEB structure, what are the component that is tending towards a dead load? So first of all, the higher portion of the PEB building is a roof sheeting. So there is some particular weight for every sheeting. So and then the next portion is purlins. So these are the purlins generally used to support the sheeting. So we have to consider the load for sheeting as well as purlins. So we have to consider the weight of these two can be considered as dead load. And the main other thing is self weight of the structure itself, nothing but self weight of the frames or columns. And then the other thing, live load. This is the next other main component in a gravity load. So live load, there will be some maintenance for every PEB building. They should be properly maintained, that should be corrosion proof, because we need more durability, right? So we need to paint it thoroughly, so that for some maintenance, some men will take care of the work. For that, we need to add live load. Generally in a PEB structure, the live load ranges from 60 kg per meter square to 100 kg per meter square. How these live load can be applied, we'll see in the design in the next lecture. And then collateral load. So what is the collateral load? Other than the dead load and live load, any other miscellaneous load the customer is requiring can be called as a collateral load. For example, if customer wants a false ceiling in the building, so this false ceiling will impact some additional dead load on the roof because it will be hanged from the roof. So there should be some certain collateral load we have to add in the gravity loads. And then next, coming to the lateral loads. What are the lateral loads? Generally, we observe the lateral loads in a PEB structure. First, the main thing is wind load. Generally, in case of RCC, generally up to G+2 or G+3 structures, we do not consider any wind load. But in RCC, in PEB structure, for any building with any height, maybe 2 meters or 3 meters or 10 meters or 17 meters, 20 meters, for any height, we have to take wind load into the action. And the next other thing, seismic load. This is the main difference. There will not be any seismic check for generally G+2 or G+3. But in the PEB, we will design the PEB structure according to the seismic loads also. And the last one, self-restraint forces. I think most of you did not know about this. What are the self-restraint forces? Because in case if you take RCC structure, there is only a huge amount of concrete and there will be steel, lesser amount of steel when compared to the concrete. So there will not be any temperature effect there. But generally, steel constructions or steel materials have higher thermal expansion than an RCC structure, right? If the temperature is more, the steel tends to expand, and if the temperature is below than the room temperature, it tends to contract. So generally, all these steel components which are manufactured in plant are manufactured at room temperature itself. So in case in future, if the temperature is increased, so what will happen? So we need to take thermal stress, nothing but temperature load, into the account for loading. You can see temperature load in the steel structures only. You cannot see them in RCC structures. So how the load can be transferred? So there is a roof sheeting on the roof, like there is no roof sheeting shown here. So all you can see, the longitudinal bars you are seeing, these are not bars. Generally we call it as purlins or jet sections, you can say. So all these will be purlins. All these purlins are to take the support to roof sheeting, right? So the roof sheeting, the dead load will be transferred directly to the purlins, and these purlins will transfer the dead load to the columns and rafters, and then columns will be take rest to the ground. But there are this is all about gravity loads. So what about the lateral loads? Nothing but wind and seismic. So generally wind will act in x direction and z direction, right? Gravity loads will act in generally, if we take y-axis up and x and z-axis as ground, right? So why live loads, gravity loads, nothing but gravity loads like dead load, live load, and collateral load, they always act as gravitationally downward, right? Nothing but y downward. But in the lateral forces, they act in x direction and z direction. So these forces can be transferred by using roof bracings, wall bracings. Here you can see some X type portions are there, no? So these you can say them as, if we use them at roof, you can say roof bracing, and if we use them at wall, you can say them as wall bracings. And then these are the various tools available for a PEB design. The first one is StatPro. I think all of you have basics about StatPro in your BTech career itself. So this is a stat analysis and design program which is generally used for design of any RCC or any structure. You can use it. So generally the main tool is here. This is StatPro. And the next one, 𝗖𝗋𝗄s. This is an advanced tool which, when compared to the StatPro, directly can model, and also you can extract diagrams from 𝗖𝗋𝗄s. And the third one, MBS. Generally, most of the people do not know about this software. Okay, generally the license of this software is very highly cost, and some of the companies only will take the license of this. MBS means metal building software. Metal building software. This is developed by MBS Web company in California. Generally, there is no Indian code design option in MBS software. So only AISC, American Institute of Steel Construction, codes will be available, and some codes like International Building Code and Euro codes are available in MBS, but there is no Indian code option in MBS. And the fourth one, Tekla. This is a modeling and design software other than the 𝗖𝗋𝗄s. And some in-house tools are there by companies. Suppose, for example, some companies uses SmartTest. This is an in-house tool by Kirby. Generally, you can say my company, we are using SmartTest as a tool. Some there are in-house tools developed by company itself. So what are the Indian codes available for a PEB design, and what are the American codes available for a PEB design? We'll see here. Generally, I think most of you know, all of you know that in the BTech or BA, you can study, this is IS 800. This is a code of practice for general construction in the steel. And IS 875, this is the code of practice for design loads. And the next one, IS 1893, code of practice for earthquake resistant design of structures. As I already addressed you, the seismic is more predominant in PEB structure, so that we have to design the help of IS 1893. And the last one, IS 801, this is the code of practice for use of cold formed steel in structural design components. And if you see American codes, AISC 360, what is meant by an AISC? Nothing but American Institute of Steel Construction. 360 is nothing but unified. Generally, you can say 360 degree, nothing but completely. So there is everything related to steel in this code itself. In the Indian codes, we are using IS 800 and 801 for different types of steel materials, but there is AISC 360. There is for all the structural steel specifications, there is one code that is design specifications for structural steel buildings. Everything will be there in AISC 360. And the next one, ASCE 7, American Society of Civil Engineers 7. Nothing but 7 is the reference number, and there are so many revisions here. The latest revision is revision 16. Okay, so ASCE 7. This is the specification for minimum design loads for buildings and other steel structures. American code specification, this one. And the other one is IBC, International Building Code and Universal Building Code. We have to use these codes in the American Code of Design for PEB. So I have taken references from these codes. ASCE 360-05. Generally, in modern days also we are using 2005 code itself, but there is a latest version, AISC 360-16, and but most of the clients prefer to use 2005 code only. And AISC 7, I have told you, minimum design loads for buildings and other structures. Yes, the other thing is MBMA. MBMA means Metal Building Manufacturers Association. So this is some different association when compared to the AISC 7, that is American Society for Civil Engineers, and the other steel contractors, and they have formed a society with Metal Building Manufacturers Association, and they developed a manual based on AISC 75 only. And while coming to the next class, just you have to observe IS 875. I think IS 875 is all of code of practice for design loads, because there are 1 and 2 dead and superimposed loads. You have to choose part 3 only for design of PEB, because 1 and 2 will be different from RCC. Okay, there will not be a use of any part 1 and 2 here, but you have to use part 3 for PEB structures, that is wind loads on buildings and structures. And the next one, IS 1893, criteria for earthquake resistant design of structures. In this, you have to study, there is some seismic map of India with different colors. Okay. So please adjust. Someone is drawing lines over here. Please adjust your cursor. Okay. So you have to study the seismic map of India. There are some certain zones, zone 2, 3, 4, 5. So what are the seismic zones we have to consider according to the place, and calculation of seismic coefficients. Yes, that is very important in PEB design. And the next one, AC 75, as like IS 875, there is AC 75. What are the different design loads to be considered for PEB building? That is chapter 6. You can see wind loads. So while coming to the next class, please go through this, and we'll see the use of these codes. Thank you. If you have any queries regarding this introduction to PEB class, you can ask me now, or you can say chat. I think.
Thank you so much, Ganesh sir, for your knowledge and experience.
Yes.
Such a knowledgeable session we have. And thank you so much, attendees, for joining with us. We are open for doubts and queries. If anyone have any doubts, please feel free to reach out, sir. We are flexible according to your needs.
So someone is asking how PEB is extremely durable. Uh, you know, as I already pointed out, with the better QC, because better QC can be achieved because the most of the PEB components. Sorry, anyone disturbing? No? Right. Okay. So most of the components of the PEB will be manufactured in the factory itself. So better QC can be achieved. There will not be any involvement of any imprecise handling of materials, so that they can be directly transported to the site, and with minimum QC you can achieve maximum result. And how it is extremely durable, we are using steel here. I think you are talking about some corrosion like that. But if you regularly paint or using epoxy primers, some clients is asking approximately 3 coats of paints. By using all these coats of paint, you can control corrosion. By doing that, it can be extremely durable. And what is the practical width? What about more than 80 meters? So what about more than 80 meters? Yes, this is the question. Just now I have shown some BC portions, BC2 itself. You can add as many as internal columns without affecting your purpose, right? You can say BC5, BC7, or otherwise BC there is if it is 80 meters, the ridge height will be more, nothing but the rise will be more. Instead of that, you can use multi-span gables. You can like that. I have shown you multi-span. You can use that. As many multi-spans you can.
Pardon my interruption, sir.
Yes.
Attendees, you can find feedback form in the chat box. Please share your valuable feedback with us.
Okay. Is with that you have mentioned for different types of frame is same for structure with EOT. Yes, EOT is electrically. EOT means, I think, cranes. You are asking about cranes. One Aditya Kabra.
Yes,
Yeah.
sir. I'm asking about crane.
Yeah, is with that you mentioned for different types of frames is the same for EOT. Yes, I'm again telling you that there will not be change, practical width change for EOTs, because due to the cranes there will not be any additional dead load on the roof, because we are discussing about the module for roof self weight, right? EOT will be on the columns, nothing but you can say lateral load will be more due to the EOT. So there will not be any effect of EOT on the module. And the other one, IS 1893 dealing with seismic, dealing with steel for seismic design, how the manual checks that. Yes, I'll tell you all these, how to calculate seismic coefficient by using IS 1893, how you can calculate manually, and how it can be compared with STAD. You can, in the STAD, you can observe seismic coefficient. So how to check seismic coefficient, and you can compare the manual seismic coefficient, and you can compare it can be compared to the STAD. How it can be compared, I'll tell you while designing. And okay, maximum span and maximum height possible in PEB structure. Yes, of course. Generally, there are 2 types of structures according to the ASC specifications. Height less than 60 feet or 18 meters, that can be called as low-rise structures, and height more than 60 feet or 18 meters, it can be called as high-rise structure. The wind coefficients, there is difference in wind coefficients. I'll tell you how they can change. And every component, every components in PEB is plastic design. Yes, this is the one thing I want to tell you. Elastic design or plastic design, and what are the types of types of sections, that is a compact section or semi-compact section or slender section. I'll discuss all these things in the next coming lectures. And what will be the weight of PEB structure per square feet? Yes, this is the one question. If you gain experience in a PEB design, you'll know. Generally, per square feet, you are asking. Generally, in metric units, I can tell you, if that is a BC, nothing but BC column, there is one column. If the span is if the width of the building is less than 40 meters, and if it is a BC structure, you can take maximum as 19 kg per meter square. Like that, you'll gain experience with all of this. If it is an RF, you can take it as 20, 23, 20, 23 to 27, etc., based on the roof dead load and live load, and based on the panels you are using. And what is the density of the PEB structure? That is what he's asking again. Why PEB vendors mix different codes? Why not purely Indian codes? Sorry, that is the customer requirement. You cannot judge that one. According to the customers, only PEB vendors will take. Right? What is the maintenance required for PEB structure? As I already told you, proper maintenance need to be done. Nothing but there should be painting should be done with or without sandblasting for at a regular intervals, so that steel structures can be controlled from corrosion. And why are we considered zero moment at base in column? Will fixity is zero there? Yeah. Yes, the very important question here. There are generally two types of supports we use in PEB structures: a fixed support and a pinned support. I have shown a PEB structure that is moment zero, that is with a pinned support. I think I forgot to tell you there. That is with pinned support. At a pinned connection, there will not be any moment. That's why it is zero moment at the base of the column. If there is fixed support, the column cannot be tapered, because there will be moment at the base and there will be moment at the top, so that you cannot taper the column. You have to use straight section for column if it is fixed base. Just make sure this point. And where are the PEB factories available, particularly in central India? Just that depends upon companies. Different types of companies available: pep spinner, and so many companies could be, and most of the companies are there. That depends upon companies. Yes, sure, please show them on project instead. Okay, surely I'll show you once here. What are the topics covered? Yes, all this sorry, is PSA members considered? No. PSA members cannot be considered as a PEB structures. Can we do PEB with RCC structure? What do you mean this one? Can we do PEB with RCC structure? No, actually, I think there will be one possible solution here. If there is one RCC structure, but you want to cover the roof with suppose you want to construct an auditorium over the roof of the RCC structure by using existing columns, you can lay a PEB over an RCC building. That is possible in that case. Is that weight including sheet? Which one? No. This is not including sheeting. Sheeting will be, I think I told you about BC column weight kg per meter square, right? So that is not including sheeting. Is precast buildings? No, precast buildings not come under PEB. And you are saying about 19 to 27 meters. No, for rigid frames up to 30 meters, 19 to 27, it is not including sheeting. And if we design is which will provide us the less tonnage. American codes always provide less tonnage because they will allow us to taper the sections. How do we decide pinned or fixed base we should go for? Yes, this is the main question. Sorry, I'm taking much time here. Just all these just hello Srinivas.
Sir, I'm here to help you.
Okay, just make sure all these questions, if possible, you can make it in a text pad so that I'll make answers to the reply. So there are around 28-30 messages are there. Okay, if I go through all these messages, it will take much more time than the expected.
Yes, sir, we'll do that.
Okay, if you make a word pad or text pad with all these questions, I'll note a reply to you. Okay.
Okay, sir, we'll run a Google form and send it to you.
Thank you very much.
Yes.
And someone asked me to show a practical building which is designed in a STAD. So I want to show one particular. There are two types of frames. Just I think all of you know. You can see here, right?
Yes, sir.
Yes, this is a STAD Pro user interface which I am using a Connect edition, and this is the plain frame, that nothing but 2D frame, that is loads applied in the frame will be in XY plane, right? This is a 2D frame I have designed. So these are the generally loads we apply like this. What are the cases, load cases we are using? I'll tell you in the design. Like this, we have to apply all the loads. This is the live load and this is the collateral load. Wind loads we apply like this. Okay, this is the one frame I have designed in. This is the 2D frame I have designed in STAD. The other thing, there is 3D frame here. Yes, this is the 3D frame I have designed in the STAD. This is a very important structure. Width is very small, but this is the very important structure because you can observe here the columns are not coming onto the ground, and also there are no some certain BC columns, so that we are using jack beams here. So in future lectures, we'll see how to use these jack beams. We can call it as jack beams. You can see here, these are jack beams. So how we can use jack beams, and we can call them as at the sidewalls, we can call it as wind girders. How we use wind girders along with portals, we'll see in the later on classes. And the next thing in the next classes, we'll see introduction to STAD Pro, and what are the features available and what are the modifications done in STAD Connect edition when compared to the V8i, and what are the different features available in STAD Connect edition. And there are some certain methods available for analysis of beams and portal frames. There is analytical method in nothing but you can directly in the user interface itself, you can apply directly loads, etc. And there is other thing in the STAD editor, nothing but like writing a program. Some certain, I think all of you learn about C something in the C++. You can hear about all these things in the CSC. It is also the same thing, like you have to write a program to analyze a beam or a portal frame. How we have to write a program in the STAD editor method, I'll let you know in the next classes. And all these things we have seen introduction to PEB industry in this class. And Yes, the main thing is load calculations. What are the load calculations involved in this PEB? How seismic coefficients can be calculated, how wind coefficients can be calculated. We cannot apply directly wind to the column or rafter itself. We cannot apply directly. There are some certain coefficients for walls and roofs separately. So how we can apply all these, we'll see later on classes. Self-restraining forces, how we apply all these things, and what are the different load combinations of steel structures by using different types of cores. We'll see. And what are the real-time projects I have done, and I'll show you some examples how to design a plane rigid frame, space rigid frame, and nothing but I've shown you something that is just a 3D building, that is space rigid frame, a portal frame design, and conventional steel structure. What is the difference between conventional and PEB, and what are the truss type steel structures we can do, and the main thing is the PEB is all about optimization. How much optimized we can do. Optimization, how much optimization we can do in a PEB building, that matters us. So how you can do optimization, what are the techniques, different techniques involved in optimization, and how to rectify the errors which cause generally most of the people will face errors in the start pro. How we face all these errors and how to rectify them, we'll see in the later classes. Is there anything else in this introduction class you want to know?
Sir, as we discussed, roof sheeting.
Yeah. Hello.
Roof. How?
Sorry, your voice is causing some disturbance. Can you tell me again, please?
How roof sheeting is economical than the normal ones? Like while casting of our roof, we are placing of roof sheeting, right?
Sorry, I didn't get you. While casting?
While casting our roof, we provide the roof sheeting, right?
Yeah.
Roof panels.
Yeah.
How it is economical than the normal process like shuttering and other things? Like.
You want to know how it will be economical, right?
Yes, sir.
So, comparing with RCC, yeah?
Not like that, sir. We are placing of RCC roofs with roof sheeting, right? Bottom of roof sheeting, after that RCC was placed.
Okay, I think you are asking about a flat roof structure, right?
Yes, sir.
Okay, yes, tell me. I understood. So
how it
will be economical, you are asking about?
Yes, sir.
So, yes. So how it will be economical, you know, flat roof structure is generally, most of the people for flat roof structures will not go for PEB structures. That's why, because there has to be some additional joists. I have told you, flat roof structure in the PEB is the only thing uneconomical. The remaining all the structures will have lighter sections, but for the flat roof structures we have to take the dead load is much more than for a nominal roof sheeting material like sloped roof. So flat roof structure is uneconomical, but it is completely safer than an RCC structure. If you go with an RCC structure, and the same thing will, if you compare with PEB structure will be more safer than this one.
Yes, sir. Thank you, sir.
Okay, sir. Sorry to interrupt you again. Due to some time imbalances, we need to move forward.
Yes.
Firstly, thank you so much, Ganesh sir. Such a great ambience of yours. Looking forward for more sessions with you. And as you mentioned, sir, with your permission, I'll share the details of the program.
Which one? Yes.
Thank you, sir.
Is there anything else? Right?
Yes, sir. Sir, can you hear me?
Yes, I'm hearing you. Please tell me. Yeah.
Okay, Ganesh sir. I would like to know about the connections.
Yes, for sure. You have to, the main concept is here connections in the PEB building. So all these can be covered in advanced workshop later on the stages. You'll learn.
Okay, sir. Actually, sir, we are giving 5 hours to STAD, right?
STAD, yeah.
Yeah. Why, sir? Like we can give much time to the structure design, the design part.
Which one? Just can you move your screen to the down, please?
Screen to the down.
Which one? Someone is sharing screen, right? The course content. Okay.
Yeah,
I'll see the course content. Just.
Yeah. Sir, what about the design part?
I'll cover the design part, right? I have just told you, if you listen to the end of the lecture, listened it, then I have told you how to design a plane frame, how to design a space frame, how to design a 𝗓𝗏. I'll cover all these topics. Don't worry about it.
Okay. Thank you, sir.
Good evening, sir. This is Srinivas. Is there, will you provide any reference material or stat files, sir, for our future reference? Means,
sorry, I think this is the company intellectual property. I cannot provide you the stat design files, but while designing the file, definitely I'll give you a program. So, or something, I'll give you a I'll give you a program so that you can directly paste it in your editor so that you'll get directly.
Yes, sir. Sir, means I'm not asking exact file. Like we want to practice at our home because
this is a company intellectual property. I cannot directly send you, right?
Yes, sir. I'm not asking a practice session at our home.
For sure.
Anything apart from your personal which you worked at. Not company
surely
property.
While designing or while starting the design itself, I'll give you a program that you can directly paste it in the stat editor. If you close the stat editor, then you'll get directly the frame and you can analyze it.
Sure, sir. Just for workouting at home.
Okay, sure. I'll provide you.
Thank you.
And I'll provide you the wind load calculation. Wind coefficients calculation sheet if you want. Then I'll provide also.
Sure, sir. Thank you.
Thank you, sir. Thank you so
Hello.
much, attendees.
Hello.
Yeah.
Sir, as you mentioned, the weight should be between 19 to 27 kg per square meter. How many component in this weight is included?
Yes, as I have already told you, the main components here are frames. Nothing but columns and rafters, including frames and purlins, girds. That's it.
That's it. It means the overall
connections also, including connections. Yes.
Including connection.
Yeah.
And hardware connection bolts also.
Yes, connection bolts also, everything.
Sir, one more question. How do we decide the pinned or fixed base?
Yes, that is the main. I think I have answered, right? No,
okay. I didn't, sir.
No. Yeah. Yes, I understood. Yeah. If the wind force is more, firstly, generally, most of the main economical thing is that we have to provide pinned connection because the footing will be lesser, right?
Yeah, you're right, sir.
Footing will be lesser. So mainly, generally, try to go with the pinned base. If you see, the sway is coming much more than the limit. Generally, there are some certain deflection limits, for Indian codes or for ASC codes, there are some certain deflection limits. This should be within the limits.
That is exactly what my question is. When we do assign pinned support, the deflection value will be more.
Yes. Exactly.
Then how do we control that deflection?
That is why we can call it as rigid frame. No, transfer forces will be transferred to the rigid frame connection only.
Okay.
Right? Rigid frame connection only. So if you provide more haunch portion, nothing but the connection at where rafter end column
I got
will be
it.
connected. That is the connection haunch portion. If you provide more haunch portion, the forces will be transferred easily and sway can be controlled easily.
Okay, got it.
In that case,
Thank
also
you.
not controlled, then we can go for flexibility.
Okay, thank you.
Yeah.
Thank you, sir. Thank you so much, attendees. Please find your doubts and please fill the Google form. Due to some time imbalances, it's high time. Sir, can you permit me to allow this course?
Yes. You can say.
Yes, sir. As sir mentioned, we are very excited to launch full course on pre-engineered building. The whole courses will be 16 hours of time. We can have the classes on every Saturday and Sunday for 1 to 2 hours time. The price of the course is 3,999 rupees only. Sir already provided a detailed introduction about the course content. It will be very helpful for us. Registrations will close tomorrow. Limited seats only available. And I mentioned the registration link in the chat box. Please find that. I hope everyone is clear. If you have any other queries, please mention that in feedback form.
Hello.
Yes, sir. Thank you. Thank you for your great presence, sir.
Hello, ma'am. My name is 𝗪𝗵𝘆 𝗘𝗂𝗂 and I'm from 𝗪𝗵𝘆 Islamia.
Yeah.
Ma'am, I want to know, sir, from the sir that is PV structure technique has started in India or not?
I hope you're clear with my words. Please fill your doubts in Google form, which we mentioned. That's a feedback form. Please fill there. Sir will answer your questions. Sir will answer every question of yours. Due to time imbalances, we are unable to continue this. We have extended this course for more interaction sessions. Please fill all your doubts in feedback form.
Okay, ma'am. Thank you.
Thank you so much, Ganesh sir. Thank you so much for your presence. We learned a lot. Looking forward for more sessions with you.
Okay, thank you all, everyone. Hope you understood what I have told. Best of luck, everyone. Stay safe. Thank you.
Thank you, sir.
Thank you.
Attendees, if you have interested, please reach out in WhatsApp group. We'll clear all of your doubts and anything. I mentioned the registration link in the chat box. Please register there.
Just I'm leaving, ma'am. Thank you.
Thank you, sir. I hope everyone clear with me. And let's wind up the session now. Thank you. Stay safe and stay home. Good night. Thanks for the presence.